Thank you, sir. Thank you, Naveen, sir.
This
Thank you,
meeting
Ayush,
is
sir,
being recorded.
for the introduction. So before starting, I'd like to thank everyone for joining this session. And Naveen, sir, has already introduced me, but still, I'll take a few minutes to tell a little bit about myself. What is my background? What is the technical background that I'm coming from, and why I am, at a position of taking this session. So, as you know now, my name is Pratik Singh. I am working as a data science associate in TCS. So I'm part of an IoT source team where I'm responsible for data analysis, data visualization, creating machine learning models, and working on data science projects. And I have experience working with the healthcare industry, automation industry, automobile industry. I've worked with data of a lot of different industries. So and a lot of clients that are in top 5 Fortune 500. So yeah, that's about me. Also, I'm a student of MIT. I was a student, so I passed out in 2020. That's a very great time I had there. That's all about me. Now I'll start the session. I'll share my screen, but before that, I'll try to tell you a little bit about the session, what we'll be doing, and how we'll be utilizing this 1 hour. So hope my screen is visible, and we'll start the session now. As I said, it's going to be a non-technical session. I'll try to give you as much as I can about data science and its application. It's the session is more focused towards the people who are either looking to crack into this industry or who have basic knowledge and they want to do something in this industry. Okay, so we'll start with the agenda of the session, and we'll end up with the questions if we have time. And so moving to the agenda and starting the session now. So the very first thing we'll be going through is the need of data science. So it is like going into the problem, and I will tell you the solution of the problem. And I'm also telling you right now that the solution is data science. Whatever problem I'll be telling you, the solution of that problem is data science. So then we'll move on to what exactly data science is and how it is being used in real world business applications to solve the problems that we face in the real world business. Then I'll take you through a sample use case. So sample use case is this use case is a very universal use case. It's very useful. It's very simple, but very effective in the field of data science. And this use case will make you understand better how data science is exactly being used in businesses. Then we'll go through what exactly is a data scientist. So there are a lot of misconceptions and misunderstanding towards this profile. A lot of people think that if you're working in a data science project, then you become a data scientist. No, this is not the reality. Even I am not a data scientist yet. I have two other colleagues in the joined in this session. They are also working with me. They don't even call themselves data scientists because you cannot just call yourself a data scientist because you're working in a project of data science. Then we'll go through what are the different skill sets you actually have. And we'll go through the must and we go through whatever you should have to crack into this industry, crack into this field. And a lot of very interesting skill sets are there. And yeah, we'll go through that too. Next point is data science job roles. As I said, data scientist is not the only job role in the field of data. A lot of other job roles are there. You might find one job role interesting and one job role is totally boring, and it can happen. But a lot of job roles are there, a lot of opportunities are there, and so we'll go through that too. Then we'll cover up the data life cycle. So data life cycle is basically nothing but we'll be going through how data exactly flows in the world of data science. And I think this is the most technical we'll be getting into the session. So we'll end up with data lifecycle. So we'll start with the need of data science. But before even starting with the need of data science, if you will notice that I haven't actually created a slide for need of data science and what is data and all, because I believe that these things cannot be written down and explained. So we'll start with the data. What exactly is data? And again, I'm mentioning this. I'll try to make this session as simple as possible without using a lot of technical terminologies and all. So definitions will be there, but they will be very simple and day to day normal language definitions will be there. So we'll start with what exactly data is. So data is, let's say, absolutely nothing but just a piece of record mentioned somewhere. So if you write something on paper, it becomes data. Whatever you see in front of your screen, it becomes data. Everything that you see, everything that you mention somewhere, it is data. Now the most important part is data is always meaningless. There is no meaning to data. You cannot say that, okay, this is data and this is this makes any sense, this makes a meaning. There's no meaning to data. Data science is used to make meaning out of this data, to get information out of this data. You won't even believe the amount of data that we are actually creating every single day. So I'm not sure about the number, what exactly the number is, but it is somewhere around 2 quintillion bytes of data every single day that we are producing, sorry, not even using. And just for information, there are 18 zeros in 1 quintillion. So we are producing a lot of amount of data every single day. And the number is not even sure. No one is sure about the number. Organization have done their studies, but no one is sure about the number. But assumption is we are creating that much amount of data every single day. Now, if I say we are creating this much amount of data, should we just let it be worthless? We shouldn't use it, and we are just producing the data and it is there in servers and we're not doing anything about it. So then the field of data science was introduced, because if we are producing something in that much amount, then we should use it to for betterment of industries, for betterment of business, for getting information. At least we should study whatever we are producing. So then the field of data science came out. The data science, now I'll go into the need of data science. So as I said, data we are creating every single day, we're creating like tons of amounts of data. So data science is used to manage the data, to process the data, to get information out of the data, to see what kind of patterns are there in the data that we are producing every single day. So this is all what data science is all about. We'll come to the technical parts of data science, technical definition of data science in the later slides. But right now, data science is all about managing and handling and getting information out of the data that we are creating creating every single day. Now, if we are creating that much amount of data, how we are doing that? What are the data sources that we are creating this data from? So a lot of different sources are there, but three major sources of data creation are evolution of technology, IoT, and social media. I'm not saying that they are the only three. There are a lot of other sources too. I'll have kept them in the other section. So we'll start with the evolution of technology first. So as you can see in this image, you see right here, this, I believe, is the most evolved technology in the last 10 decades that we have, a mobile phone. We used to use a landline. There was a wired connection. Then we moved on to wireless landlines. Then we moved on to handsets. Then we moved on to colored mobile phones. And then now we have smartphones that can do absolutely anything. So as we have evolved with the technology is now creating a lot of data. Every single click you do on your mobile phone, data creation is happening, data processing is happening. You cannot even imagine whenever you search something on Google and you press that search icon, you cannot even imagine the amount of data that is being created just by you clicking that search icon. So energy evolution of technology is one of the major sources of data. Then we'll move on to IoT. IoT, probably people know about this, but I'll still explain what IoT exactly is. It is like two or multiple devices connecting, through internet and communicating with each other. So this is all in a nutshell what IoT is all about. IoT data is a very major data source. I'll give you an example of that too. Probably you've heard of automated air conditioning units, right? So in rooms, we have automated air conditioning units with that will automatically turn off or turn on or increase or decrease the temperature based on the room temperature. So there are two units in that automated air conditioning unit. Number one is a sensor that is reading the temperature, and the number two is that air conditioning unit itself. So the sensor here is creating a lot of data. It is reading the room temperature, and then it is creating data for air conditioning unit. And then this air conditioning unit is processing this data and then making a decision out of it. As I said, data science is all about making decisions. So here also data science is used, and IoT is creating a lot of data sources. IoT is like if you go for professional and industrial level, IoT is the biggest data source that is present till date. Social media, arguably one of the biggest major data sources right now. I think I don't even have to tell you how we are using social media to create data. Every single like you do, every single comment you do, every single tweet you make, a lot of data is processed and created. I read somewhere that whenever you make one tweet, there are 3 to 4 terabytes of data that has been created and goes into the Twitter server. So that is also a data source. If we talk about others, what are the other data sources? So other data sources are like transportation, banking, retail. Whenever you make a payment, the data is created. So as I said, data is created. Every single thing you do in the day, data is created. A lot of data is created, by the way. So there are sources that we cannot even cover in just 1 hour. So these are the major sources of data. Now we know what data is. Why do we need data science? What are the data sources? Now let's move on to what exactly data science is. What the definition says about data science. So here's the definition in front of you on a screen. I will run through it. I will read it through, but I don't recommend you to understand this because this is a bit of a technical definition. We'll do one thing. We'll run through this, and then I'll tell you in very simple words what exactly data science is. So the definition says that data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from noisy, structured, and unstructured data, and apply that knowledge and actionable insights from data across a broad range of application domains. So a lot of technical terms were also there in this definition. Just to make it simple, I'll tell you in very simple words what data science exactly is. So data science is all about getting a piece of data, applying some statistical methods, processes, and mathematical algorithms on it, and finding out some insights and information out of it. And then when we have the information, we cannot just leave it floating around us. Using that information for better decision making is what data science is all about. Extracting the information and then using the information for better decision making. And this all is happening on data. So in simple words, this is what data science is all about. You can take a screenshot of this definition. I'll also share this entire slide, all the slides in the chat box later. But try to understand what the definition is saying. But in simple words, I've told you what data science exactly is. Now we know what data science is, what data is, why do we need it, and all. Everything is now we know about this all. So now let's just move on to if there is something in this world, how this thing is exactly being used in the real business applications. So how data science is exactly being used in real business applications. So you see 7 business applications here in front of you. These are not the only 7. We cannot even imagine the amount of applications that we have and that are using data science. Just for your, for the sake of applications, most of you probably heard about automated toilets. It's a very funny and very uncommon data science application, but this is also a data science application. So the amount of applications, the number of applications, we cannot even imagine how many are there. But these 7 are the most common in the industrial world of data science. So we'll start with each of them. I'll give you an example of each of the single application, and we'll see. We'll try to make it as simple as possible. So the number 1 is fraud and risk detection. So fraud and risk detection, I'll give you an example of that. Whenever you go to an ATM, you put your card in, you take the cash, and you just leave. Have you ever imagined what exactly happens in that ATM machine? So because an ATM machine is also a computer, right? So whenever you put your card in, a lot of algorithms run in the background. And these algorithms are actually reading the data that was created when you inserted your card in the ATM machine. So what these algorithms are doing, they are just trying to validate either it's you or someone else trying to do this on your, on your side. They also read the patterns that you make. So now you might have observed that ATM machines also ask you to, insert a 2-digit number. So all of these things are based on data science. All the algorithms that are used in the ATM machines are based on data science. Another example is whenever you log into a site, you put your credentials in. Now we have automated captchas and all. They ask you if you're a robot or not. So all these things are happening on data science. Why they are happening? Just to detect if there's some kind of fraud happening or if there is any risk to the system that you're using. This is where fraud and risk detection uses data science for. Now moving on to e-commerce. E-commerce, everyone nowadays, we all use e-commerce. We all use Amazon, Flipkart, and all these things. E-commerce uses data science in probably majorly in the recommendation systems. So you also might have observed this. Whenever you put something, in the search bar of Amazon, suppose you have put, you decided to search for a phone with a particular price range with some particular features. Now the results that will come out will not only be that particular phone. the phone that you searched for, but you will be shown every single phone in that Amazon is having right now, with that specification, with that price range, with that common features and all. A lot of phones will be suggested to you. And how is this happening? This is all happening based on a data science algorithm. So recommendation algorithms run on the background of e-commerce applications. They recommend you stuff that you are most likely to buy. Data science is used again here. Gaming industry. Now gaming industry is totally based on data science. Let's say you're playing a game and you make a decision of either going left or going right in the game. Based on your decision, the game will make its own decision. If you go left, the game will show you a totally different thing. If you go right, the game will show you a totally different thing. How is it happening? It's all happening based on data. The game is already programmed in such a way that it will read the data that you will create, and then it will make decisions. It will increase or decrease the difficulty level just to keep you engaging in the game. So that's how data science is used in the gaming industry. Gaming industry is one of the industries that is basically absolutely nothing without data science. You might be thinking that data science is new and gaming is like a very old industry. Data science is not new. Data science is I think way older than the gaming industry actually is. So gaming industry is totally based on data science. Then comes healthcare. So healthcare uses data science not to directly interact with consumers. Healthcare is more about using data science for research and biotechnology. So we don't see a lot of data science, in the real world in healthcare industry. But healthcare industry, if there was no data science, then you cannot even imagine the solutions of healthcare issues that we have in the real world. So healthcare industry is also using a lot of data science, solutions. Automobiles, I don't have to tell you, smart cars we are having now in the world. Cars are making their own decisions. They are driving by their own. So all of this is happening based on data. Data is the key of every single automation in the world right now. So automobiles are also a part of them. Then moving to target advertising. Now this is a funny thing. Have you ever observed, if you try to search something in Google, let's say you try to search for an iPhone, and the next thing you will see is your entire phone will be covered with the advertisement of this particular iPhone, and probably with the same color that you search for. How is it happening? These organizations that we use on day-to-day basis, they take the data that we create and then they use this data against us. So this is how target advertising is done. They are showing you the advertisements that you will definitely buy at some point, because you will see it too much in front of you and you will definitely buy it. So this is how target advertising is done, and this is all done using data science algorithms and data science solutions. Risk management, if we move on to risk management, the best example is weather forecasting and the weather department. Weather department uses data science for risk management in terms of weather. So whenever there is a storm coming, the farmers, weather department informs them, and the farmers take whatever is the needed actions they have to do to save their crops and all. This is just one example of risk management. There are a lot of other examples too. Now, as I said, we'll move to a use case of data science. So now we know what data science is, how it's used in the real world. Now we are moving to a use case of data science. And it's a very interesting use case. You'll love it because it's a very common, very simple, but a very effective use case. So this is what Walmart did, I think in 2014 or 2013. So Walmart, for those who don't know what Walmart is basically Big Bazaar, but at a global level. So yeah, it's a chain of retail stores. So what Walmart did was in 2014, I guess, Weather Department of USA, they declared that there is going to be a tornado in a very short time. So all the businesses around in Georgia was the place where the tornado was hitting. So in all businesses around Georgia, they were trying to be ready for this challenge, and they were trying to reinforce their business, and they just wanted their business to not get impacted because of this tornado. So Walmart also was one of them. So Walmart took a totally different approach. What they exactly did is they consolidated the last 10 years of their data. And the data is basically the product sales, the customer behavior data, and all these things. So they consolidated last 10 years of data, and then they tried to find out a pattern in that data. So what they were looking for is, whenever there is a tornado in the last 10 years, they just wanted to know what are people exactly buying. Whenever there was a tornado, what people exactly bought. And the six products that you see here, the list of six products, were the top selling products whenever there is something like a challenge like a tornado was coming. So people were buying heavy waterproof boots, first aid kits, ginger lollipops, surprisingly, peanut butter, whistle, and crackers. So if you go for human expertise, if I ask you what would you buy when you will go, when a tornado is rushing towards you, I think crackers, you won't even imagine buying crackers. But the data said that, okay, people will also buy ginger lollipop and crackers whenever there is a tornado. So what Walmart did is Walmart just decided to go with the data, and they stocked up all the stores in that area with these 6 products. They put these 6 products on the upper shelves where people can directly just reach out to them. And surprisingly, in just 2 days of this announcement, all of these 6 products were like sold out. People bought them again. Walmart again stocked up all the products in all the stores, and again in just 2-3 days, all the products were like sold out. So the story here is Walmart decided to go with the data. What data is telling them is basically to stock up these 6 products on the shelves, and they will sell them. Because in last 10 years, people bought these 6 products whenever there was a tornado. So Walmart used the data for better business decision making. Walmart simply used the data for better sales. So this is how data exactly is used in real time for businesses. And this is just one example of Walmart. A lot of industries, a lot of organizations, they use this, do the same thing to increase their sales numbers. They try to find out a pattern in the data of last maybe 10 years, 20 years. If you want it be more accurate, you just increase the time, read the rate of 100 years. So you will be getting more accurate results, more accurate predictions. So this is how data exactly is used in real world. Data science exactly is used, so we'll say that. Now, as I said, we'll talk about the role of data scientist. There are a lot of misconceptions about this role. People, misunderstand this role because a lot of people are like, if you're working in the field of data science, you are a data scientist. No, that's not true. So I'll take you through what exactly data science is. Again, we'll go through the definition first, and then I'll simply tell you what exactly it means. So the definition of data science says that data scientists are analytical experts who utilize their skills in both technology and social science to find trends and manage data. They use industry knowledge, contextual understanding, skepticism of existing assumptions to uncover solutions to business challenges. Again, it's a lot of technical terms are there. So just to make it simple, a data science is just someone who is using his technical skills, business skills, mathematical skills, and data. Combined all these things together, they're just simply trying to find out a trend and pattern in the data, and they're just trying to make better decisions out of it. So data scientists are basically people, with a very huge arsenal. So they have expertise in a lot of different industries, a lot of different technologies, and a lot of different domains. So you cannot just be a data scientist by running machine learning models. And so you have to be, very accurate. If you are saying that you're a data scientist, you have to be very sure about if you really are a data scientist. Again, data scientist is basically nothing but a person who uses technology, mathematics, and business, and combine these all things with data to make better decisions. Now, data scientist is a role. We have a lot of different roles as well in the field of data science. I'll talk about that too. We have a slide for that. We'll talk to that about. And the skill sets that we require to crack into this industry. So if you're looking to go, in the field of data science, if you're looking to start working in the field of data science, these are the skill sets that you should have. Some of them are like you must have, like a programming language. You always should know a programming language. I see a lot of institutes that are claiming that they will make you a data scientist without any prior knowledge of programming. It is not true. You cannot be a data scientist without a programming language. You need a programming language for that. So we'll cover each of them one by one, and I'll tell you, which one to start first and which one you can start in the very end. So we'll start with statistics. Statistics is basically nothing but a branch of mathematics that deals with data interpretation, data collection. Everything that happens with data is happening because of statistics in maths. Then we'll move to programming language. A programming language, I'll say you should go for Python if you want to work as a data scientist in any organization, in any project. Start with Python, be good at Python, and then there is another language that people use in data science, and that is R. You see here, Python and R both are mentioned. So start with Python, be good in Python, and then go for R. Then the next thing you should understand is data extraction and processing. So now a lot of database technologies comes into action when you talk about data extraction and processing. So you should be aware of DBMSs, the languages that are used in DBMSs. Also some Python libraries that are used for data processing, like pandas and all. So this kind of knowledge is also very important. Then the second part is data. Other part is data is data wrangling and exploration. So data wrangling and exploration, understand what data exactly saying, just play with the data. It is all about the data analytics part, like trying to find the insights out of the data. So for this also you need Python, you need some libraries of Python, there are a lot of tools present in the real world for data exploration and data wrangling. You can go for that. Then comes machine learning. Machine learning is like it's a buzzwords of I think this decade. Machine learning is every single person here might have already heard about machine learning. So machine learning, again, in simple words, is basically nothing but us giving a machine ability to learn, think, and make decisions, all based on data. So this is machine learning all about. Don't be an expert in machine learning. You don't have to be an expert if you want to go in data science. Just understand how machine learning models work, how data is used in machine learning and all. So that is enough if you want to start something in data science. Then we have big data processing frameworks. So as I said, we are producing 2.5 something quintillions bytes of data every single day. So whenever the data is in a very huge amount, then we call it a big data is a term that is used for that particular amount of data. Now, if I say you have 2 terabytes of data, we are still talking about big data. If I say we have 2 terabytes of data and you have to process the data, you have to use scientific methods on this data to get something information or some insight out of this. How would you do that? 2 terabytes of data cannot be processed on your local hardware. Because people have, most probably they have 8 GBs or 16 GBs of RAM. Some of them have 32 GBs of RAM. You cannot process 2 terabytes of data on your local hardware. So for that, you need processing frameworks. Frameworks like Hadoop and Hive. I'm not asking you to be an expert in, again, Hadoop and Hive. Just try to understand what they are, how they work, what is the architecture of these frameworks, because that's the most important part. Again, then the most important thing, the most underrated and most important thing is data visualization. So data visualization is something that is used, like, it's the very first step in every data science project. You try to visualize this data. I'll explain this to you with an example. Suppose I put 100 numbers on your screen, random numbers arranged in random order, and I ask you to find the largest number out of these 100 numbers. It will at least take you 2-3 minutes to traverse through all these numbers and find the maximum number out of it. Now, what I do is I plot these numbers in a bar chart. So bar chart is basically nothing but something you see here in the image of statistics. This is basically a bar chart. So what I am doing right now is I am just plotting these 100 numbers in a bar chart. And now I'm asking you to give me the largest number out of them. So what you will do is you will look for the longest bar that is there on a plot. And you will say that, okay, this number is the largest number. It only took 5 to 10 seconds to figure out everything. Plotting a bar chart and then reading that bar chart, it only takes 10-15 seconds. But randomly arranged number, if I asked you to get the largest number out of it, it will take you a lot of time. So data visualization is all about making data processing and data insights easy to understand and to read. Data visualization is used for data storytelling, so it is the most important part. Now, what should you learn first? In my opinion, you should always go for programming language first. Go for Python, be good in Python. Then you should start working on your statistical methods and all. Then move on to data extraction and data processing. Then data wrangling and data exploration. Data visualization start parallelly. Whenever you start data extraction, start data visualization parallelly. You can use a lot of data visualization tools like Tableau, Power BI, and a lot of open source libraries are also there in Python for data visualization. So keep it a parallel, task. Then machine learning and big data, go for them, but in the very end. Machine learning and in the very end also start with machine learning first. Big data is, even I am not really comfortable with these big data frameworks right now. So big data, it is used, but it is not that much used because it's a totally independent technology there. Big data is a totally independent technology. A lot of other things are happening in big data. So to be an expert in big data, you need a lot of different other technologies also. So go for big data. Just try to understand what big data is. Start with Python and with big data. So this is the skill set that you require. Now, as I said, data scientist is not the only role in the field of data science. There are a lot of other roles you see in front of your screen. I'll walk you through each from each and every single role, and whichever you find interesting, just go for it. Don't even try to force yourself to be a data scientist. It won't work out, because to be a data scientist, you have to be an expert in a lot of things. Try to find out a suitable role which interests you the most. Go for that role. I'll take you through each role. The very first one is data scientist. Data scientist, as I said, is a person who's responsible for getting insights out of the data by using their skills, technical skills, mathematical skills, business skills, and all. So, and then using that information for better decision making. Now, a data scientist alone can do a role of data analyst, data architect, data engineer, and statistician. Not a database administration. Maybe someone is able to do that too. But as I said, data scientist, if you want to be a data scientist, you have to be expert in a lot of different technologies. So don't even force yourself to be a data scientist. Moving on to the data analyst. Now, the role of data analyst is to get the data, to do operations of the data, to get insights and information out of it, to try to find out patterns and all, try to find out what can be done on this data, and if there's something that we can do on this data, how can it be done. So all of this is related to data analyst profile. Then comes data architect. So whenever you start a data science project, the very first thing you try to do is to get the data from the client side. Because data is something that shouldn't be leaked. Data is a highly secured thing. You should handle data very carefully, especially when it's someone else's data. So data architects and data engineers, they both work in this segment. Data architect is basically someone who makes this blueprint and a vision of how data will be moved in the entire project, how the data will be moved in, how one particular team will access this particular amount of data or this particular piece of data. So the blueprint is designed by this data architect. Data engineer's role is to convert this blueprint into the reality. So data engineers are responsible for moving the data, exactly moving the data from point A to point B, with transforming it into a relevant manner. So that's where data engineers comes into action. Then comes statisticians. Statisticians are domain experts. So basically they are mathematicians who have every single knowledge of statistics and how data is used in terms of maths. So statisticians here are responsible for help and support to data scientists, data analysts, and sometimes data engineers also. They also need statisticians. Not very often, but sometimes in some projects it can happen that statistician, sorry for the word statistician, is helping a data scientist, data analyst, and data engineer as well. Then we have database administrator. So a DBA, this is the short form of database administrator. It's a very famous role in the world of data science. So this person is responsible for maintaining the databases, giving the access rights of these databases to all the individuals. So everything that is happening with a database is done by a database administrator. He's responsible for the well-being of a database, how the database is being used, who is using a particular database. All of these things are done by database administrators. Then comes a business analyst. Now, business analyst and a data analyst, both of these profiles clash a lot. The only difference here is business analyst is more focused on the business part of the data. The business analyst only motive for a business analyst is to get the data and to make a business solution out of it without doing a lot, without playing with the data a lot. But data analyst, on the other hand, is responsible for exploring every single aspect of the data. If there is even one single thing that can save, let's say, ₹1 or $1, data analyst should know about it. But the business analyst is all about getting the data and how important this data is for our business, what we can do in this data to make better decisions of businesses. A data analyst can take over the profile of business analyst, and I think it will happen in future. Data analysts will be able to work as a business analyst as well, because business analyst is only extra thing that business analysts are doing. They are only just interacting with the client as well. That can also be done by data analyst, and we also do it in our projects and in our profiles. We also do it. We interact with the clients. So business analyst is not something that will, I think, that will not last long in future. Data and analytics manager. So this is basically a manager of all these profiles. So this is someone who manages all the other profiles in a team in a project of data science. So to be a data and analytics manager, you probably need a master's degree in, let's say, a management of or data. You need a master's degree to be a manager. So this is someone who is just controlling every single thing happening in a data science project. Now we know the rules of data science. I hope you found out the interesting one, whichever suits you the most, whichever you like. Now we'll move on to the very last topic of this session, that is data lifecycle. We'll spend a little bit of time on data lifecycle because this is very important. And this topic is basically about how the data is moved in the field of data science. How we take the data from a source and then we convert this data, just a piece of data, into a data science solution that is capable of a lot of different things. So the very first part of this data lifecycle is business requirements. So this part, business requirements, is not just it's not just a first part in this data lifecycle. In software engineering also, business requirements is the very first part. Business requirements is basically nothing but to understand what exactly needs to be done. What is the objective function? What is the problem statement? If we have to work on this particular project, then what exactly needs to be done? A lot of client communication happens on this business requirement section, because if anything goes wrong with business requirements, entire project can break down after spending a lot of resources and time on the project. Just an example, suppose you mentioned something in a wrong format or in a wrong order whenever you are trying to understand the business requirements, and you worked on this wrong format or pattern, and then the entire solution was created, and then you realize that business requirement was wrong. Resources are wasted, time is wasted, a lot of things are wasted, and most importantly, the trust is gone from the client. So business requirement is something that we have to do very carefully, and we take a lot of time doing that. Managerial level individuals are a part of this kind of conversation whenever business requirements happen in the real world. Then we move on to data acquisition. So data acquisition is like, now we know what needs to be done. Now we know what the client wants. Now we know objective function is, problem statement, whatever it is. Now we know everything. The second thing, the most important thing, is how we are getting the data, because in the end we have to work on data, right? Everything is happening on data. How are we getting this data? What kind of data we have? How are we processing this data? Everything related to data gathering happens in the data acquisition part. Data engineers work on this data acquisition part. So they are responsible for ETL. ETL is basically nothing but extract, transform, and load. So they extract the data from client servers, they transform the data in relevant form to make it more relevant to the team that will be working on the data, and then they load the data in the project server and another server also, where the copy of the data is stored. So in the field of data science, data copies are most important thing, because we need to have backup, because we are running on data, right? And data is you mistakenly can restore a memory card. So basically what you did was you just formatted a memory card. Now everything in that memory card is gone, right? All of us probably have done it in once or twice. So backups are most important. Data acquisition is responsible for backups, for getting the data, for everything related to data. It happens in data acquisition. Then comes data processing. Now, step 3 and step 4 are mostly for data analysts. So data analysts work on data processing and data exploration. So data processing is all about when we have the data, then processing that data to make it more meaningful. Because when we get the data could be very noisy, the data could be very rough. Sometimes we remember that we get the data in a form that cannot even be processed. So to convert that into a form where we can actually use this data to to do something, data processing is basically that section where we do these things. Then comes data exploration. As I said, data exploration is all about going and finding out the insights from the data. So we explore the data. We explore every single part of the data, every single aspect. We don't leave even one single record from the data. So we try to find out. We already have the objective function because that's what we did in business requirements. So we try to find out how we can actually achieve that objective function, how we can create a solution that satisfies the objective function. So all of that is happening in data exploration. Then comes the next part, that is data modeling. So data modeling is basically all about trying to find out the target variables, trying to find out what are the data what the parameters are in the data that can be used for creating models and all, for creating solutions. So machine learning modeling is also here, and data modeling is also one part that can be done after data exploration. Projects, they prefer data modeling after data acquisition and data processing, but a lot of times it happens that data modeling is also done parallelly with machine learning modeling, because just to understand how both of these things will relate together. Probably it wouldn't make any sense now, but when you will work in a data science project in real time, you will understand where can modeling happen. Like modeling can also happen at a data acquisition point, modeling can also happen in machine learning modeling point. A lot of things can happen, a lot of the sequence can change. Sometimes, not of very often, but sometimes the sequence can change. But data processing and data exploration will always happen in the same sequence. Then comes the very last part, that is deployment. So deployment is basically nothing but putting that solution that you have created on a platform where that solution can be used by someone else. So you used the data to create a data solution for better business requirements, better business decision making. Now everything is done, you have created a solution, but you need people to use that particular solution. And that is where deployment comes into action. You basically just deploy this solution on a client server or somewhere else where a client will be able to access this. So this data lifecycle, try to spend more amount of time on this data lifecycle, because this is a very important thing to understand how data exactly flows. All the steps you should spend, explore all the steps, try to find out how it is used, and what are the challenges that are faced in every single step, because business requirement and data acquisition are the two steps where most of the challenges are, and data processing is the most time taking step. So we spend almost like 70% of our time in just processing the data. So it might sound very simple that data processing is all about cleaning the data and all, but a lot of things are there that you need to understand in data processing. Data processing is a completely different field in itself. It is a standalone field. You have to understand a lot of technologies and tools to understand data processing as well. So data lifecycle is one of the most important part. So try to explore more about data lifecycle. Now, this is we are coming towards the end of the session. So as I said, it's going to be a non-technical session. If you really want to have a technical session, if you are interested in this, data science and how technically applications are made based on data science, based on data, then you can definitely request about a technical session. You are probably a part of a WhatsApp group. You can request Ayush sir or Naveen sir or organizers about the technical session, and we can, if everything goes well, we can organize a technical session as well. But a technical session cannot be done in just 1 hour, so we need more time for that. So if you are really interested into that, you can request for that too. So this is from my side, this is the end of the session. This is what we can, you can understand in terms of non-technical part of data science. I tried to make it as simple as I could. And yeah, that's it from my side. Now, if you have any questions, you can ask any questions, but try to make your questions relevant to the session. Don't try to go in technical part, because I understand a lot of people are here also working in data science projects and all. But this is not a session for technical aspects, so don't try to ask technical questions. If you have technical questions, you can again go for a request and for a technical session, and we can do that too, and then we can cover up some technical questions as well. So yeah, that's it from me. And now it's all up to you.
Pratik, one question is in chat box. What are the skills required to get an entry level job in same domain? That is asked from Ujwal Jindal.
Okay, I have covered the slide. I will go back to it again. So as I said, start with a programming language, work with statistical methods, go for be at least good in Python, because there is a myth that you can be a data scientist without a programming language. It cannot happen. Start with a programming language, try to understand what are the libraries in that particular programming language related to data science, then go for statistics, then go for data extraction and processing and data wrangling and exploration. To get a basic entry level job in the field of data science, I would say that job will be a job of data analyst. And to be a data analyst, you should know at least programming language, data visualization, and statistics, a little bit of statistics. So I hope that answers the question. So
Yeah, Pratik, we have two more questions. Very
yes, sir.
first question is, what are certifications required which will make ourselves a certified data scientist? This is amongst question asked by one of our students from MIT itself.
Yeah. So I think it's a very good question. So there is no specific certification that you require. So data science is not like a networking industry where you require a Cisco certification, where you require some other certifications. Try to get as many certifications as you can, but don't force too much on certifications only, because in the end what happens is people write down 10 certificates, 12 certificates in their profile, and they got stuck in the interview when interviewers actually ask about certifications. Because honestly, we all know whenever we do a certification, we are more focused on just getting the certification rather than learning about what is exactly happening. Certifications are good. I won't say that don't go for them. Go for certifications, go for reputed organizations for certifications. Don't just take certifications and waste time in normal websites that are available. A lot of certifications are there on internet. So try to get at least certifications in data visualization. A programming language certification is I think is a must. And a little bit about libraries of Python for data exploration and data processing. So if you have these three certifications, I think that's more than enough to get a basic entry level job.
We have one more question, Pratik. What is the importance of metadata in data modeling?
Very important. Metadata is one of the very important part. So for those who don't know what metadata is, I haven't covered this in this session. Metadata is basically, in simple words, data about data. So whenever you receive a data, there is a lot of information that comes with that data. Because as I said, data is basically a meaningless record. So we also need information to at least relate to that particular piece of data. And that's where metadata comes into action. So metadata is one of the major things when we create data summary reports, when we do data received reports, meta and data modeling also. Metadata comes in very handy, because data scientists or data science individuals, they are not domain experts. I've worked with a lot of different industries. As I said, I've worked with healthcare projects, I've worked with energy management solution projects, and I'm not an expert in either healthcare or energy management. So how do I know what the data is exactly telling me? Because the data is basically just numbers and terms that I've never even heard of, right? So for to understand that, metadata is one of the very major things. And so you should never ignore metadata. You should always, before going through the data first, go through the metadata. And always use metadata for data modeling, and because it comes very handy whenever we have to work on data modeling and all. Yeah.
Okay. Next
Hope that
question we
answers the
have,
question.
Pratik. Do we need to learn DSA, or it will help us in any way to grab a leap while starting with data science?
As I
Basically, the
said, if
question
you
in
really
short
want,
is they're asking about DSA. Is it necessary to learn DSA, or we can go without learning DSA also? That's the question.
without learning, it's all up to you, right? If you really are interested into it, just go for it. If you're not interested, if you it is, I would say it is necessary. But again, start with a programming language, start with data visualization skills, start with machine learning methodologies, and you will be able to get a basic entry level job with a data scientist. And one more thing that I will tell you, you will only learn real data science in a job. You cannot learn data science from going through courses and certifications. This is the reality. If people are saying that you can be a data scientist just by doing a course, it's not going to happen. So start with it. Whatever you want to learn, it doesn't matter if it is necessary or not. If you want to learn it, just go for it. But to get a data science job, a basic data science job, go for a programming language, start data visualization, start machine learning models, and that should be enough for an entry-level job in data science. And most importantly, work on a profile. A lot of people, what they do is they focus more on technologies. Like the question is, should we do DFA or not? It is good, do it. It's all up to you. It's all your interest. It is required. I'm not going to say that it is not required, but basic technologies are enough to get a basic data science job in any service based industry. If I tell you that if you really want to get a job in a product based organization, then you have to be a little bit of an expert to a lot of other technologies also. So hope it answers the question. I cannot say don't go for it. I cannot say, it is the only thing that you should learn. So go for it if you are interested. It is necessary, but it is not that necessary. You should understand it, by the way. Like, you have to have a knowledge of this.
Naveen sir, I think that all the questions are covered.
Oh, I can see one. I can see one more question in chat box.
Okay.
Some Aditya Bagal is asking, sir, I opened Lenscard 1 month ago till now. If I open YouTube, Chrome, the Lenscard ad pop up, how I should stop it?
How you should stop it?
Yes.
Okay, I'll go back to the slide. If you remember in this slide, I talked about target advertising, right? So this is what target advertising is all about. Whenever you went on Lenscard, you tried to find out glasses or something, and then, as you said, next thing you see, you open YouTube and all the ads are related to that particular product that you search on Lenscard, or basically you will get offers from Lenscard in your ads. You cannot stop it. Sad part of it, you cannot stop it, because whenever you downloaded the Lenscard app, you actually allowed the permissions to get the data from you and then use to organization, and then the organization is using that data against you because you allowed them to do that. So that's why whenever you download an application, go and the permission section comes up, read it and then do it. If you really want to stop it, don't use it. That's the only thing I can say.
One more question.
You cannot stop.
Which programming language is mostly used in data science, Python or R?
Python is the majority of times it is used. In the majority of projects, Python is used. R is also used, but it is not that common. It is a very good language. Again, start with Python. Be good in Python first, then start with R, because a lot of organizations, if you are just going for jobs, then Python is a must. So Python is very good. And also Python comes with a lot of open source libraries that are very helpful in data science. So libraries that you probably haven't even heard of. So Python packages are very good. Python libraries are very good, and Python is simple language. So a lot of time Python is preferred. So go for Python first and then go with R.
Well, Pratik, you will be surprised to see that your friend Shan from your batch,
yes, he's also here,
has joined since the beginning and
Yes,
is
sir.
listening very patiently. So can I request Shan to throw some light on the data science or any domain of your choice? Shan, can you hear me? I think some network glitches there on his end.
Yeah, probably he's not able to hear us.
No, not an issue.
Yeah. So if we have any other questions, then we can go to that. Or from my side, it is all done. It was a pleasure, having this session with you guys. And again, thank you very much for joining the session.
Pratik, one more question is still left. Somebody is asking, is it possible to learn Python language without basic languages like C and C++?
Yes, it is possible. But if you really want to be a good software engineer or data scientist, I would recommend you to go with C first. And I think probably if you are in this session, you are probably in an undergraduate course of computer science or data science or something. So in these courses, they teach C in the very first year. So C is basically a language that allows you to understand how programming languages actually work. The only motive of teaching C is to understand how programming actually works. So it is possible to go for directly for Python, but yeah, if you're not interested in C, then just directly go for Python. But I'll suggest you to start with C first. At least have an idea of how C is working, because a lot of processes and a lot of operations are there in C that come very handy when you start with any other language. So yeah, you can go for Python directly. No issue in that. Python is a very simple language. It doesn't require you to have any prerequisite or not. It's a very simple language. So directly you can start Python as well.
Yes, sir, I think that all the questions are answered now.
Yes, I think it's over now. So we can wind up. Then. Yes. Thanks.
Well, on behalf of MIT Merit, I would like to express my gratitude to Pratik for giving an insight about data science. Many participants in this webinar are from the non-technical stream too. So they too must have gotten clear idea about what is data science and what are the applications in business. I hope this webinar will prove fruitful to all the attendees present here. And last but not the least, I would like to thank Pratik once again for sparing his valuable time from his busy schedule to enlighten us on one of the upcoming technologies like data science. In future also, Pratik, we will seek your guidance and we will plan some more technical sessions as you stated in the session of 4 to 5 hours session we will take either weekly or monthly so that everybody has an insight about how to build a career in data science.
Yeah, sure, sir. It's my pleasure that I had a chance to take this session. And as I said, if we get enough requests for technical session, we can definitely go for it.
I think as per the previous question I had, your two friends were also there in the webinar.
Yeah, yes, sir.
So your another friend is also here in the webinar, Pravesh Unayal. So Pravesh, just propose a vote of thanks. I am just granting you access to your friend. I'm granting rights. And one more announcement I'd like to make, that Pravesh will be the next speaker in this series, Alumni Connect 20, and he will be discussing about the Salesforce domain. And the webinar is scheduled in advance in future, that is on 12th of March. Same time, 11. Yeah. Pravesh, can you hear me?
He's writing.
No, you need to open the mic and give a vote of thanks to your friend. Yeah, he's joining as a panelist. Okay. Just a second. All the rights are given, Pravesh. Now you can speak. Pravesh, unmute the mic.
Yeah, hello.
Yeah, we can hear you.
Yeah, good morning, sir. Good morning, everyone. Good morning, Pratik Singh. Pratik, it was very wonderful and informative session. I enjoyed the full session and just information that you shared with us. And yeah.
Thank you very much. It's my pleasure.
Yeah, sure. And looking forward for some more sessions related to data science in future also.
Yeah, but before that, we are also looking a session on a Salesforce.
Yeah, sure, sir. Sure, sir. As per my words, I will do that.
Yeah, sure.
Yeah, sure. It's my pleasure.
So today we have 3 alumni in this webinar from batch 2020, Pratik Singh, Shan, and Pravesh. Shan is a coding expert.
If you allow, just a quick shout out to my colleagues also. They are also in this webinar. Junaid Khan and Tanya Agarwal.
Tanya Agarwal.
Yeah, Tanya Agarwal, Junaid Khan. They probably won't be comfortable in being a panelist because.
Okay, I'm granting them access to speak if they want to speak. I granted access to Tanya ma'am. And other name, what you said?
Junaid Khan.
Khan. Could you spell out the name?
Probably he's left the session. He just texted me that he left. Yeah.
Okay. So Tanya ma'am is here. Ma'am, would you like to add some few more points?
Hi.
Hello, ma'am.
Yeah, so I think pretty much covered everything that we are currently doing in TCS, and it was a very informative session for me as well. He actually jotted down the points very nicely. So thank you, Pratik, for this session from my side as well.
Thanks, Tanya.
And last but not the least, I would like to thank all the participants because their participation is motivating us to arrange more sessions in future. Am I right, Naveen sir?
Correct.
Okay. Participants, I already shared the feedback form link. Please fill that form. I'd also shared in that form 2 more sessions. The very first session is on how to handle stress, which will be conducted in association with IIT Kanpur today itself at 3 p.m. And the topic is how to handle stress. And for tomorrow, we have another session, a coding journey to product-based companies. All those links I have shared in the form. In case you are interested to attend these sessions, you are most welcome to be a part of those also. Already shared the joining link, registration link. So hope to see you all in the other webinars too. Thank you, Pratik. Thank you, Naveen sir.
Thank you all. Thank you, Pratik. And thanks to
Thank
all.
you, sir. Thank you, everyone, for joining the
members who are-
session.
Thank you.